Hello folks, bit of a long day today. In fact, it's been something of a long week for me, so don't be surprised if my thoughts are a little bit disjointed in this episode. But I did want to make a video for you and update you on the PCS situation. Now the good news is we have our PCS here on the bench working perfectly now. Turns out that I was more or less correct in what I'd assumed, that the problem was down to the firmware revisions on the PCS having different expectations of the CAN messages. So it was a lot of trawling around, a lot of banging my head against a concrete wall. But we finally got the differences down, at least between two revisions now. I'm still waiting on a third PCS to arrive. So when that does, we'll put that on the bench also and see how things go from there. Now, what I've done since that discovery, so I've completely rewritten the software for the PCS controller. So the PCS controller, the STM32 version now has a new software for it. Now it's still based on the whole open inverter system, and I just basically ripped off quite a lot of the hard work that Johannes had done, and then I'm obviously going to pass that off as my work so that I get the dollars. Anyway, got a few extra features in there for you, so we'll get on the screen grab here now in a minute and I'll walk you through that. I'll put a link in the description to the GitHub repo where you'll be able to find binaries and sources for that software. PCS controller itself, the hardware is the very same. Has not changed, and I don't envisage making any changes to it, and I don't, think that there will be a need to, other than, maybe just a few additions, like a few extra LEDs or something on the board just for me when I'm doing my debug, but that will have no implications for end users. So let's get on the computer here and we'll connect to the PCS here on the bench, and I'll show you a little bit of a walkthrough on some of the menu items that we now have, and then that'll be it. Okay, so just here looking at our kind of a crude hacky controller that we showed you the last time. So before I tear this down and put the STM32 back on the board and start working on the firmware for that, I thought we'd give you a quick demo here of the PCS functioning. So we have our high voltage supplied courtesy of the land yacht. Our PCS controller is ready to go. So I will first of all press E for enable. We'll enable the PCS, and we have enable on. So we can activate the DC-DC converter first. We'll press F for that. Should see the converter come alive. Yep, we got DC, high voltage DC comes alive, and low voltage, and our low voltage current and voltage and all this comes alive. Now, in order to turn the charger on, I'm going to have to kind of jump around a little bit here, so to move my desk chair, because this is a manual test rig. So I'm going to hit G to enable charge, and then I'm going to have to just jump over here to the socket and turn on AC. So we'll go enable charge. I'll run over here, turn on the mains. Let's see, we have AC voltage now applied. And if we ask the charger for some power, so we'll say for 500 watts, P500, we'll hear our PCS starts groaning, and we can see starts delivering power, and we can even go up a little bit on that. Let's go for P700. I can't push too much power through it here because number one, I don't have the wiring for it, and number two, I've no coolant flow. So that's our PCS charger and DC to DC converter working. Let's go back to P0 there just before we heat anything up. But it is working. We can go back again. You can go P500 again. And the PCS wakes up again. And back to P0. And that's it. Recording. Okay, so welcome to our web interface here for the PCS controller. Everything here is your pretty much standard open inverter interface. So we'll just jump straight in and I'll describe some of the parameters here. I'll skip fairly quickly through these ones here. They're pretty standard. So 0 PAC set point is our charger power set point in kilowatts. So we can go from anything from 0 to 11 kilowatts, and our charger will attempt to draw that much power from the AC input. IDC limit is a DC current limit, so it will attempt to adjust the AC input power to follow that limit. IAC lim is a maximum value that we might want to draw from the AC mains. This IDC set point I've actually disabled in the current firmware, so I can take this parameter out. UDC set point will basically throttle the charger back once we reach this, whatever we specify here, output voltage. UDC lim will shut the charger off when we get to just slightly above whatever set point here. Time limit will shut our charging off if we specify a time limit. And time delay here will basically hold off starting charge for whatever time in minutes that we specify. So that's all pretty standard stuff. Input type here, we've got three choices: type 2, type 1 and manual. Obviously type 2 and type 1 refer to a type 1 or a type 2 input socket, AC input socket, depending on what jurisdiction that you may be in or what type that you may want to use. Manual basically overrides that plug detection that you would have in either of those sockets and kicks off the charger manually. Now, under those circumstances, you would have to connect your AC and DC separately. IDC, KI and KP here, you can ignore. I'll be stripping those out. They won't be doing anything. Activate. So we've four choices here: none, charger, DC-DC, or both. Obviously the PCS contains a charger and a DC to DC converter. So this little menu here lets you decide what combination, or indeed none of those, you may wish to activate. Now things get a little bit interesting down here in the general area. So we have an alert log here, and we have a choice to have that on or off. I'll explain the function of that in a minute. And then we have a little kind of a dialog box here, or we can specify which alert in that log that we may wish to look at. So I'm going to skip right down to the bottom here, and don't worry, we will come back to looking at that. The rest of the functions, I should say, but I'm bringing you down here because this is a new addition to the firmware. So down here we've got PCS alerts, and we have PCS alerts counter. Now the PCS and all of the Model 3, and I guess really all of the Tesla stuff, is quite good at telling us over CAN what its ailments and complaints may be. And what I've done is I've integrated some of that into the firmware here so that we can determine if we've a non-working controller and PCS combo as to why that may be. In order to kind of make it more easier for end users to operate, the firmware will now decode all of the 91 alerts that the PCS can provide and give us a text description of what that alert is. And the alert counter here will basically tell us how many alerts that we have in the matrix. The matrix presently can store 10 alert events. You can store as many as you like. We could store 100, we could store 1,000, but at some point it kind of becomes a bit ridiculous. And usually if your PCS is generating more than 1 or 2 alerts, then that's something that we need to address. But for the purposes of diagnosing why that things may not be working, this is the kind of go-to area here. So I've ran the controller deliberately here with no AC and no high voltage DC connected in order to generate some alerts, so I can show you how that system works here. So if we scroll back up here to our dialog box, we can choose which alert number we may wish to look at. So in this case, we put in 1 and press enter. We scroll back down and refresh, and this is our first alert that we have stored here. It is alert number 66 in the matrix, and it says DC-DC HV rationality. So what that means is that the PCS, the DC to DC converter side of it, is telling us that we are attempting to start up the DC to DC converter, but we are not providing high voltage DC for it. So it's complaining about that. So let's see what else is on the PCS's mind. So if we select alert number 2, we get our next alert. It is number 76, and it says DC-DC enable de-asserted error. Now this is a fairly interesting one because this happens, it's more of an artifact in the software that when we shut our charger down, there's a little bit of a delay. It's only a few milliseconds. Or sorry, when we shut the DC-DC down, There's a delay of a few milliseconds between when we tell it to shut down over CAN and when we disable the hardware line. And that creates an alert here, basically telling us that we're deasserting the enable line for the DC to DC converter while we're still telling it via CAN that we want to run. And so on, we can basically work our way here through whatever alerts that we may have stored. This one will have been stored because I was playing with the software. And what it says here is it's alert number 20. It says charge enable line mismatch. And what that means is that I have told the charger via CAN that I would like it to start up, but I have not correctly brought up the enable line. So we've got a charge enable line mismatch. So it's really quite a useful diagnostic tool to find out what may be going on. And likewise here we've a DC-DC enable line mismatch because I was again playing with my software here and it's just been generating alerts. And there we go, we're back. It's just generating the same again because I've been, as I say, playing with the software and so on, but it was useful here to leave the alerts stored so I could demonstrate them. Now, if we want to clear that alert matrix here to start fresh, what we can do is we can select alert log off, and then if we come down here and just refresh one more time, it'll basically have cleared the alert counter and cleared the alert matrix. And then obviously you can leave this alert log off during normal operations, but if you wish to diagnose problems, you can turn alert log on. And then when we next power up the PCS, and I'll demonstrate this here, obviously I have no high voltage and no AC connected at the minute, so I'm just going to go select manual run, so that'll try to start the charger and the DC-DC converter. So we'll just refresh there, and we see we have PCS alert counter has gone up to 4. That's usually what it generates. It usually generates 4 alerts under this circumstance. So what I'll do is I'll just put that just back to type 2. And that will probably have generated 1 more alert. It should be up to 5. Yep, so we got 5 alerts now. So I'll put my index back to 1. And there we are. So we've alert number 28, charger output UV, which stands for under voltage in this case. So what it's complaining about here is that we've told the charger that we would like it to start up, but the high voltage is less than what it would like to see. Obviously in this case it's basically nil. And then we can just go through our index again and we'll find similar kind of alerts in here. Yeah, so there's the same one, DC-DC high voltage rationality and so forth. So this is our alert log system here, kind of just a way of determining the why that our PCS would be unhappy with us. Now particularly we'll be looking here for if there's firmware differences between the CAN messages that we're sending and what the PCS expects. we'll be seeing we will be seeing alerts here. They'll say things like BMS MIA and things like that. The MIA in this case is, I guess, Tesla language for missing in action, means it's missing a particular CAN message that would have originated from the BMS, and we'll have to work on that. So that's just one example. So this is our kind of self-diagnostic region here. So let's jump back up a little bit here now. So just run through these quickly. Op mode just tells us what mode the controller is in. State is what state the charger state machine is in. Uptime is just basically how long the controller is powered. Errors we haven't implemented at the minute, so I'll probably just strip that guy out. UAux is the 12-volt voltage as measured by the controller. User AC lim doesn't do anything. I'll strip that out as well. It's actually kind of useful for me here because I'm seeing there's quite a few legacy parameters that we can strip out. Hardware AC limit is being read from the PCS over CAN, and it's basically telling us what the maximum AC current per charger phase, in this case because it's a three-phase model, would be. Cable lim is our cable limit, so from the proximity line, and EVSE limit is our PWM. Power AC is telling us how much power that our PCS is consuming from the AC line. Power DC-DC tells us how much that we're how much power the DC-DC converter is putting out. UDC is the DC voltage as measured by the PCS. ULV likewise is the 12-volt system voltage as measured by the PCS. UAC is the AC voltage, again directly measured. IAC, AC current. IDC, DC-DC current. IDC-DC we don't, oh that's the IDC-DC is the 12-volt low voltage current. Charge AC limit is transmitted from the PCS when the charger fires up, and it will basically change depending on what type of charger that you have. The PCS type here will tell us what will tell us the type of AC setup that our PCS has. In this case it says 16A, so 16 amp 3P for 3-phase. Charge state is in faulted here from our last little startup, because obviously we didn't have any DC or AC connected. Charger power available will populate when the charger goes into enable mode, and it'll tell us how much power that we can draw from it. That will vary depending on things like the temperature and what our line voltage may be doing. Grid config will tell us what kind of AC connection that we have, whether it's single phase, 3-phase or delta 3-phase. Just some flags here for proximity and enable line and so forth. We have temperatures as read from the PCS here. So charger module A, B and C temperatures. We have a DC-DC temperature. This one is DC-DC bus bar temperature. And we have ambient temperature. Model code doesn't do anything at the minute, but it will. And PCS boot is just reading some information about the boot loader on there, which will become relevant to us in later firmware versions. And we've already gone through the alert system. So what I'm going to do is I'm going to stop the recording here, and I'll turn on the HV, and I'll plug in I've just got a granny cable hooked up here with the type 2 socket, and we'll come back and we'll just show you the system working here on the bench. Alrighty, so we've all done our jobs, right? Yay. Okay, so we are in run mode. You'll see that the auxiliary 12 volt voltage has increased because the DC-DC converter is now on. We will see that our cable limit is 13 amps for my granny cable and about 10 amps for our cable. DC-DC converter power is about 80 watts. You'll see we now have DC voltage here, low voltage, voltage being measured, and AC grid voltage. Obviously we've no AC or DC current at the minute. We have DC to DC converter current. And down here we have our PCS type, 16 amp 3-phase. Charger state is in enable, and available charger power is about 3.7 kilowatts because we're in single phase. As we can see here, grid config is now in one phase. So we scroll down here now, we'd see our temperatures will probably already be increasing a little bit. Our DC-DC converter certainly is. Did I leave alerting on? I did, and you'll see that we have no alerts here. Our PCS alert counter is at 0. So we have a happy PCS. Now I have no charger input power set at the minute, so I'm going to do that now. Let's go for about 500 watts, so 0.5 kilowatts. We'll press enter. If we come down here now, you can hear the charger starting to warm up. Yep, there we go. We have a kilowatt here, and we'll see here that my AC current has gone to 2 amps and my DC current at 1.25. I could increase that up to 1 kilowatt. Now we'll see there we've gone to 1 kilowatt, AC current to 4 amps, and DC current to about 2.5 amps. If we come down here, we'll see our temperatures on charge phase C, which is the active phase. When you're in single phase mode, will start to come up, and our DC-DC bus bar also likes to warm up. I'm afraid I can't go any higher with the power at the minute because I've no coolant flow through the PCS, and don't want to have any accidents. So let's set our power back to 0. And we come down here now and just refresh again. Yeah, we'll see we've got 0 on our power, and yeah, our AC and DC currents are now gone back to 0. And that is about what we've got, folks, on our, let's call it a beta release of our new PCS firmware. So hard to believe there's a week's work of beating my head against a wall on this, but it works, and I think it works pretty good. So just a few quick links here in relation to our PCS controller project for those of you that will be looking for the software. It's available here, open source on GitHub. There'll be a link in the description to this. Just go into the software and the STM32 directory. You will have the software source here and information on how to compile it. And there is also a release over here. So you can go in here and you can get the binaries and a zipped source code for that very beta version that you just saw. I will be making updates to it as I kind of tidy up the interface and add some features, and there are some features on the way. Over on the Open Inverter forum, we've a support thread here. So, please do provide some feedback on here, and particularly on the alert logs and things like that you can now read with the web interface. And this will help us get more and more versions of the PCS firmware working with the controller. And finally, if you want to purchase a controller, they are available here on the EV-BMW web shop. So that's it here. Just as I say, this has been at this now since when? June 2019. Wow. Ugh, crazy. But there it is. So we're back working on this guy, and I'd like to think we're making some progress. So there it is, folks, our little PCS controller in all of its glory, and working quite well here with this unit. So as I say, when the second non-working one comes along, we will get doing some testing, and who knows, maybe it'll just work with this version. So obviously be most interested to see what happens when this firmware gets out into the wild and people start using it with their PCSs, and give me some feedback on how that works. But in the meantime, don't forget to dislike, do not share, unsubscribe, and cancel those alerts so that you don't get trapped watching any more of this garbage. Do, however, check the links in the description for the GitHub and the Open Inverter pages that I have just shown you there on the screen grab. There's some useful info there. But do ignore those links in the description for Patreon and PayPal, because if you were to foolishly support me on any of those platforms, well then I'll just do more of this kind of thing. And as we all know, nobody wants that. So folks, I'm going to leave it there. It's been quite an exhausting week with this thing, and I'm looking forward to some of the feedback from folks trying out the new firmware. And until then, all I can really say to you is happy PCS testing.